Hi everyone, welcome to eye dissection lab, your second lab of spring semester. So today we are going to dissect cow eyeball, which is very similar to our eyeball. Plus we also going to see the structures after cutting the eyeball. We will see how each structures belong to which layer and which tunic. So when we talk about cow eyeball, actually, which is very similar to our eyeball, it looks like a shape of a ball. Obviously, when we look at each other's eyes, our eyeball doesn't look like a ball because most part of our eyeball is actually hidden within the bony socket. Only little part of it we can see. And in this case, the complete eyeball has been taken out of the bony socket, so you can see the shape of the eyeball. So first thing I want to see when I have the eyeball is to understand where is the front of the eye, where is the back of the eye. So I know this structure, which is very opaque, is called cornea, through which light will first pass through, and so that has to be the front of the eye. Now we see the cornea is opaque in here. However, in living condition our cornea is not opaque, it's actually transparent. So when you keep eyeball in solution for a long time, the cornea will turn into opaque. But in living condition, for light to be passing through, cornea has to be transparent, which our corneas are. So cornea showing the front of the eye, and surrounding the cornea I see this white of the eye, which is called sclera. Now both of those, since we can see from the outside, which we call outer layer, so cornea and sclera are two structures which are part of outer layer. However, you can see how hard the tissue that's making this cornea and sclera, actually bunches and bunches of dense collagenous fiber, dense regular collagenous connective tissue, making these two structures, sclera and cornea. And that is why we will see it's hard to cut through sclera when we first want to make our first incision through sclera to cut the eyeball. So this is why these two structures we say belong to fibrous tunic. So cornea and sclera are part of outer layer and part of fibrous tunic. Okay, so we see a lot of fat surrounding, some muscle, little part of eyelid, little conjunctiva here, which we actually don't need, none of those. So what we want to see, we want to go to the back of the eye. And on the back of the eye, we look for a ropey structure, which we call optic nerve. You can recall we saw optic nerve last lab as well, when we saw optic nerve from, we saw sheep brain, and we saw that optic nerve, which is over, starting from here, from the right eye, and this is from the left eye, this optic nerve coming together into the thalamus area to make optic chiasm. So optic nerve comes from the back of the eye, from the region which we call, or structure which we call blind spot or optic disc, where there is no photoreceptor rod and cone cells, and optic nerve takes the visual information, that's the spatial sense of vision, to the thalamus of the brain, and thalamus send that spatial sense of vision into occipital lobe of cerebrum for interpretation. Okay, so once we see this optic nerve, we are ready to cut the cow eyeball. So a lot of time, if you have too many structure nearby, before cutting, if you can push the structure a little bit posteriorly, that actually helps. Now cutting eyeball and looking structure after cutting is not hard. Hard part is to make the first incision on the sclera. And just the reason we said little while ago that sclera has bunches and bunches of dense regular collagenous connective tissue, making it will be very hard in the beginning to cut through the sclera. Make the first incision, but once you make the first incision, the cutting will be much easier. So the way we cut eyeball is so that we can understand what are the structure present in anterior cavity of the eyeball and what are the structures present in the posterior cavity of the eyeball. So we will be cutting such a way that it gives us an anterior cavity and gives us a posterior cavity, and so that posterior cavity structures are not mixed with anterior cavity structure. To do that, we go to the cornea and sclera junction, and from that junction we want to measure 0.6 centimeter distance. So 0.6 centimeter is right here. So right over here will be 0.6 centimeter. From the junction of cornea and sclera, you are making your first incision on the sclera, but 0.6 centimeter away from the junction of cornea and sclera. So right over here. So I take this scalpel and what you want to do, you want to hold the eyeball tightly, but you go with a saw-like motion and you see that first incision and you see a little bit of watery liquid oozes out. This watery liquid is aqueous humor, which is found in the anterior cavity of the eyeball, and it actually keep our intraocular pressure intact. So in disease like glaucoma, doctor usually check that intraocular pressure, which is maintained by aqueous humor. Now the moment aqueous humor is spilled out, your first incision is done. So here if I look over here, where is the incision was? Right here, as you see. Very tiny. But what I will do, now I will be using my scissor, more aqueous humor coming out, using a scissor, and I make a circular cut, and I want to make sure I keep 0.6 centimeter distance, at least try my best, from all side of that circular cut. Sometimes it may go a little bit less or more than 0.6 centimeter, but you don't want to be too far away from there. Now you are feeling how hard it is to cut through the sclera, and that makes you appreciate why we say that sclera is part of fibrous tube. Alright. So the moment I cut the eyeball, this is where my anterior cavity, posterior cavity is ready to get separated. So gently, and even with all our good cut, sometimes posterior cavity structure tends to sometimes come towards anterior cavity and the vice versa, but most of the time it will be okay. Okay. So here is my posterior cavity and this is my anterior cavity. When I am seeing the anterior cavity, I see this structure which is lens, and surrounding the lens there are other structure as well. So what I want to do first, I want to take the lens off. Unless I take the lens off, actually it will be harder for me to see the other structure in the anterior cavity. I want you to pay attention when I am taking the lens off. You see a little bit of transparent structure that is holding the lens, which is coming from this black area which has ridge in it. And actually this black area which has ridge is called ciliary body, which has ciliary process, ciliary muscle and suspensory ligament. And ciliary muscle, from the ciliary muscle, this suspensory ligament comes out, which you see I am moving right now, and it's holding the lens in its place. Okay. So I will not ask you to show me suspensory ligament, but it's a good thing to see. Alright. So once you see that, gently take it out. Now lens as well as cornea are avascular, that means they don't have any blood vessel in. Part of suspensory ligament still coming out of the lens, as you see, or holding the lens. Okay. So now we are ready to see our anterior cavity after we took out the lens out, take the lens out. So first thing I want to see the front of the anterior cavity. No problem understanding what this structure is. This will be cornea. What is the structure surrounding the cornea through which we cut? This white structure is sclera. Cornea and sclera together making outer layer and fibrous tunic. As you see, my gloves has these black dots. This is aqueous humor that came out of the anterior cavity. Now I go to the back of the anterior cavity. And the moment you go to the back, I may ask you again, name the structure. And make sure you understand, since the probe is showing to the cornea, but from the back, the structure is still cornea. You may say, well, structure, can it be pupil? No, it cannot be pupil, because pupil is not a structure, pupil is a hole. Pupil is a hole, so whenever we are asking, name the structure, putting our probe right in here, we are actually asking for the cornea. If we ask you for pupil, we will ask you name the hole. Alright. Surrounding the pupil is this black ring. Directly surrounding the pupil is this black ring which doesn't have any lines on it. And this black ring directly surrounding the pupil is called iris. Now, directly posterior to the iris, you can see there are black structure which has lot of lines on it, and through which you saw the suspensory ligament holding the lens. So this structure is actually ciliary body. Ciliary body does have ciliary process which produce aqueous humor, ciliary muscle which change the shape of the lens for far vision, near vision, as well as suspensory ligament which holding the lens in its place. But for the cow eye dissection, all you have to say that this is this structure with the line on it is the ciliary body, while the structure directly surrounding the pupil is the iris. Now, iris is smooth muscle, and front of our iris is colored. So if we have green eye or brown eye or blue eye, that's the front of the iris. Now iris, the smooth muscle, has two type of muscle, which is one is circular muscle, which when contracts, it will be constrict your pupil when the light is very bright, and there is also radial muscle which when contracts, it will actually dilate your pupil in the dim light. One thing you notice, iris, ciliary body, both of those look black. Yes, there is something that's coming out. That's something that I want to mention right after that. So we already had outer layer, sclera, cornea, which was part of it. So what will be iris and ciliary body be part of? iris and ciliary body will be part of middle layer and also called vascular tunic. Now, this middle layer or vascular tunic has only iris and ciliary body in the anterior cavity, but it has another structure which is actually on the posterior cavity, which we call choroid, sometimes also called choroid coat or choroid. So choroid has lot of blood vessels which supplies nutrients to the cornea as well as to the lens, which are avascular, but it also have high amount of melanin so that it can absorb light as light comes in rather than reflecting light, making inside of the eye dark. Now choroid, remember, is also black. We will see right now. So middle layer has all these structures: choroid in the posterior cavity, which we haven't seen yet, ciliary body in the anterior cavity, iris in the anterior cavity, all are black. And that way sometimes it may be easier for you to remember that these are all part of middle layer, also vascular tunic. Now to see the choroid, which is on the posterior cavity, I have to take this liquid off. And this liquid, unlike this one which is blackish, watery, aqueous humor, this liquid is jello-like, and this we call vitreous humor. And vitreous humor actually keep the shape of the eyeball, but another thing you see it is doing, it is pushing this beige color structure that you see directly underneath the vitreous humor into the, pushing it against the back of the eyeball. And that beige color structure which we go when we go to the inner layer is actually retina, which actually has the receptor for special sense of vision. It has photoreceptor cells as well as stimulated by light, as well as it has 2 layers of sensory neurons, and one of those sensory neuron layer, which we call ganglion cell neuron, will converge into optic nerve. But first we need to see choroid, and to do that we have to take the vitreous humor out. So use your thumb. You can use probe too, but if you do use probe, be very gentle that you do not want to destroy the retina behind it. So I usually use my thumb as well as index finger, and you just push little bit, it will come easily. The whole point of the dissection is able to see everything without destroying much. So here is the vitreous humor just fell down. Okay. So a little bit left here. Okay. So first thing, before I even see the choroid coat, I have to see the retina. And retina is kind of, as we already saw, stuck on the back of the eyeball because vitreous humor is pushing it. So it's the beige color or creamish color apron-like structure. And as you see, what am I doing? I'm gently pulling the retina like an apron and making it all in one area, piling the retina into one area. Alright? Okay, so retina, this is all we can see. You see where it is hanging from. Because it is hanging from somewhere, retina is not falling down, and that particular area from where retina is hanging from is actually optic disc or blind spot, from which optic nerve coming out. Alright. And directly underneath the retina. So retina, because it has 2 layers of neurons and photoreceptor cells, the tunic is nervous tunic, layer is inner, but then directly underneath I see this black structure. And what am I doing right now? I'm separating this black structure from the back of the sclera. Don't forget, this is sclera, so the back of the sclera all the way over here, and what am I doing? I am separating this blackish structure, which in this cow eyeball also has this bluish sheen from the sclera. So right now you see the back of the sclera. This is the choroid with the blue sheen and the retina. And choroid, as we said, most part of the choroid is black, and it also tell you that it's middle layer choroid and it's in the vascular tunic. Now this bluish membrane that we see in the choroid of this cow eyeball is not present in us. This bluish sheen like membrane, this membrane which producing bluish sheen, is called tapetum fibrosum, and what it does, it make the animals like cow or sheep or dogs have their eyes glow at night time. Our eyes cannot do that, so our choroid will be simply black without any tapetum fibrosum. So I want to clean this area a little bit more so you can see everything well. Okay, so we pretty much done everything. So let's see and recapitulate. This is the outside of the sclera, outer layer fibrous tunic. This is inside of the sclera, outer layer fibrous tunic. Then we come to the choroid, the black structure, which is part of middle layer vascular tunic. On choroid, the blue membrane is tapetum fibrosum, part of the choroid. Then we come to the inner layer, which contains structure retina, as well as it is on the tunic, nervous tunic. The cavity is posterior cavity, which contains vitreous humor. Here is the anterior cavity, which had aqueous humor, and on the anterior cavity we saw whole pupil. Surrounding the whole pupil is the iris and ciliary body. With the lungs. So iris, ciliary body, choroid, all part of middle layer vascular tunic. Again, if I ask you structure, you say cornea, which is the outer layer fibrous tunic. Again, cornea, sclera, outer layer fibrous tunic. Lens, and lens actually separates the anterior cavity from the posterior cavity. Within the anterior cavity we have two chambers, anterior chamber and posterior chamber. An anterior chamber is from cornea to the iris, and posterior chamber is from iris to the lens. I hope you understood some basics so that it will be easier for you to do the dissection. Please make sure you bring your goggles because aqueous humor will spill when you do the fasting session. Thank you.